Hello everybody and welcome back to the MOSHIX mainframe channel. This is MOSHIX, and today I'm going to be making a video about some of the amazing new features that have come very recently into Hercules. As you know, when we speak about Hercules, there's two branches. There is the Hercules 3 series. We can see here if you go to Hercules Hyperion Software Labs, you see that Fish, who is the main maintainer and programmer of Hercules, he has his own company or website. He maintains he maintains the repository on GitHub, but on this website he also makes available pre-built binaries for those people who don't want to compile stuff. And and those are all Windows binaries. But here he has a Windows binary as of 2018, 10th of November, which is already quite it's already a little bit of an older version. He also keeps previous versions here. So this is the 4 series version. It's called Hyperion. That's the code name for this version. As you can see here, this is for Hyperion. And then there's also Hercules, the 3 series, which is just called Hercules, which is what comes pre-installed with, which you can easily install on on things like Debian or Ubuntu or Red Hat with Package Manager. So here I have on my ESX, my VMware cluster here, I have this virtual machine, and I have a terminal window opened to it right now. And so I can see if there's a Hercules installed on it. There is one, and this already tells me that this is the one that comes with Ubuntu. This is an Ubuntu machine. So what we can do here right now is remove that apt remove Hercules, and then we'll see what it is removing. Attention, this will be removed, that's fine. And we removed Hercules. We can try to install it to see what it is installing. Apt install Hercules. On Windows you would just go and get one of the pre-built binaries. Oh, it's 3.12. Okay, so this is the Hercules that you install when you install it through the Ubuntu or Debian. In this case, this is Ubuntu 16.04 from 2016, so it has a 3.13. If you install the newer version of the long-term support version of Ubuntu, which is Ubuntu 18.04 from this year, from April this year, then it will come with I think 3.13. Yes, pretty sure it's 3.13. So slightly improved version. However, all the new development, and that's important to understand, is going into Hyperion, and you can find it on GitHub. If you search for SDL Hercules 390 on GitHub, you'll find this repository, and this is where all the development is happening, and this is where all the innovation is brought into Hercules, and then some selected stuff is backported into Hercules 3 series. So there's no development done here anymore. They're just bug fixes, and some select features are being backported. And that's important to understand. You're really running old software if you run Hercules. Now, most people on this channel, they also run Jürgen Winkelmann's MVS 3.8 as packaged by the TK4 distribution. And in there is a Hercules 4.0, which is yet a third distribution of Hercules maintained by Jürgen, which is a mix of this stuff with some of the features from here, but it's already 2-3 years old. So that is actually quite old, even though it's a very stable version. And so I've already made a couple of videos in the past where I show how to compile your own Hercules. Now, the reason I'm making this video again is because in the last 6 months some amazing development has gone into Hercules 390, and I think you owe it to yourself to upgrade to these new features. For one thing, so let's look here a little bit. For one thing, Fish and the other developers have gone through an exercise of improving the performance of certain instructions, hardware instructions of the underlying IBM mainframe architecture, especially for 31-bit and 64-bit instructions. Some have been improved by factor of 10, some by factor of 30, some by factor of 3 orders of magnitude. So it has become quite a bit faster, and I'm very excited about it. There's also been a bunch of bug fixes where I have actually worked together with Fish and Ivan Warren, who's the other main developer, both of them amazing guys. Ivan Warren is in Paris, I believe, in France, and Fish is up in Seattle. Fish is a very nice person, always answers to bug issues very, very quickly. You can see here some of these are mine, and they work on it prompto, I mean, very, very quickly. Now, so other than making some instructions faster, they've also made it possible to run a ZVM on Hercules. There were a bunch of very serious issues with that, especially in the handling of the virtual memory handling on the hardware side. Dynamic address translation was broken just a bit, but enough that the newer version of ZVM wouldn't run reliably on it, and they fixed it, and I work with them on that. But what I'm here really today, the main thing that really gets me excited is that, and you may not be aware of that for the longest time, so for the last, I want to say 18, 19 years in Hercules, because that's how old Hercules is. It's 20 years old project. I first used Hercules in 2001, I think, or 2000. So what people don't know is that there's two types of DASD handling in Hercules. You can see here in this documentation slide, you can build either formatted or compressed or uncompressed DASDs, and you can see it here. Let me remove Hercules again just for a second. Okay, that's removed. I have a bigger font here on the window so that you can read this better. I have Ubuntu installed here. This is Ubuntu 18.04, and I have here one DASD. Now this DASD here is a compressed DASD. CCKD stands for cyclic. What does this stand again? Cyclic compression. CCKD stands for. That's a very good question. It's key count. Count key is 1. Compressed count key. Oh yeah, so that's what it stands for. Compressed count key device. So it's a very simple compression algorithm, but very effective, that goes either through the zlib or the bzip libraries, as you can see here. You can either use zlib or bzip. I'll make it a little bigger for you to read. When the tracks are being written to the DASD by the operating system, Hercules underneath uses the zlib libraries from Linux and the bzip2, which also exists for Windows obviously, to compress them on the fly and uncompress them on the fly. So this results in a much reduced size of the DASD. So, and also the DASD only occupies the file, the data that is really written there. So you can create a 3 GB DASD, and it still will occupy only a few megabytes if you just made the basic formatting and wrote some initial data into it, and it only grows as you add to it. Now there's two advantages to that. Obviously the whole directory becomes much smaller, it's easy to copy around, but also actually read-write becomes faster, because it's disk performance that we're worried about. It's not so much processor performance. We have plenty of processor performance. So compressing, uncompressing does use, of course, some processor cycles, but that's still much faster than waiting for a spinning disk to reach past track 20,000 or so. So, excuse me. So in effect, compress makes actually I/O much faster for the mainframe operating system within. So when you build a DASD, you have to say what format you want it to be. So the traditional command was DASD init. So let's put this here on the side. So we could say DASD init, and that we don't have Hercules installed. Let's install it again just for the sake of explaining this. Install only takes a second. Okay, so everything I'm saying right now pertains to the old version of Hercules, before the amazing new stuff that went into just in the last few weeks into Hercules Hyperion. But with the previous versions, the ones that most of you are probably running, if you do a DASD init, this is exactly what we see here. So I can DASD init, I can say compressed with -z, zlib is fine. Bzip is slightly better, but I always use Z because it works. I always add alternate cylinders. So, and then I give it the file name. So we say MOSHIX CCKD32. Okay, let's take number 1. And then I have to tell it the model. Now, let's open up a side discussion about IBM DASD. What those disks are. So I'll make this a little bigger. When IBM doesn't really make disk drives for the mainframe anymore, of course, that is all out on the sand. Those are all being emulated as well. They don't exist as physical drives anymore. And when you buy a mainframe, you usually buy a storage server from IBM, somebody else. Hitachi makes them, and other, of course, EMC makes them, which is now Dell, and others. And then you can just create the drives you need on them, and they're being kept, of course, in RAID volumes and all that kind of stuff. But that's on the back end. And the most operating systems today on the mainframe, such as ZOS, such as ZVM, ZVSE, and even Zilla Linux, they use 3390 disks, but there are several models. Model 1 came out with almost a gig of storage size, about 1,000 cylinders, and then Model 3 came with 2.2, 1.8, and then Model 3 came with 2.84. Now, everything that we were able to use compressed until now, even uncompressed in Hercules, had to be within the limits of 2.84 gigabytes within Model 3. Why is that? And that is really the most important part about this whole video. Model 9 already has 8.5 gigabyte, and Hercules disk access was written in 32 bits. 32 bits means you can only address up to 4 gigabytes, and that is really the problem, because we couldn't address anything beyond 4 gigabytes, even compressed or non-compressed. We couldn't access it. You can define it, but Hercules can read and write it, and that's why all our devices had to be 3390 Model 3. But there's also Model 9 with 8.5 gigabytes. There's Model 27, which is 27, Model 54, 55 gigabytes, and then EAV up to 223 gigabytes. Most people on the mainframe on professional shops nowadays work with these ones, Model 54s. And maybe for some residence volumes, still with 3, because they're easy to back up, and they can be carried basically on a memory stick, though of course in a bank you would never be allowed to do that. So we had to work, and for the longest time all we had is Model 3s here, 2.84 gigabytes. Now, just in the last 3 weeks, Fish and Ivan, but mostly Fish, he wrote on him personally by himself with a design by Greg, what's his name, Greg, we'll see him here, he writes a lot of code as well. Can't remember his last name right now. There is one more. Oh, Greg Hartman. Yeah, Greg Hartman. So with he designed, Greg and Fish designed it, and then Fish wrote 64 bits of So that is a huge game changer, because with 64-bit we can have any size 3390 disks now. We can go up to model 54, okay? And when we write model 54, for instance, especially with Zilla Linux, it's not working with 3 GB disk size. It's nowadays just too small for Linux, even older versions of Linux. So anything we would want to do at the very minimum, we would want to go with a 27 GB disk, or you would have to split it up in many disks, but then you have the problem that your files have to be located across disk boundaries, and you have to work with it. It's cumbersome. And so if you only want to play with things, which is what people mostly want to do with Linux or development work on the Hercules, because I mean, obviously the speed is not going to be great. If you want great speed, you need to be in a real mainframe. But if all you want to do is just play with it, then it's cumbersome to have to work with many disks. So you would define it with probably model 27, 27 gigabytes, or even model 54. So let's see how this works here. So we say DASD init, Z for compressed, I for allow for some here it is for alternate cylinders, and then now we say 3390 model 9, and then the bottoms here is for mod 09, volumes are 6 bytes, 1, 2, 3, 4, okay. And I don't have to give the size because it takes the size from the model. Okay, so let's do that. So now it created a disk here. As you can see, it doesn't occupy anything, just 5,000 bytes. Okay, and now this will be able, because it's model 9, to go all the way to 8.5. However, this Hercules can only see up to 3. So when you start writing to it and you go past the 4 gigabytes boundaries, results are unpredictable. Most probably some counters will warp around 0 and you're going to overwrite your disks. And so I had some people when I made my previous video about installing Ubuntu on Hercules, some people said, well, why do you take such small disk? I took a 54 gigabyte disk, so much more space. Well, yeah, I said, it doesn't really work, but they went ahead anyway. And then pretty soon their volume was destroyed. So hope they had a backup. But now in Hercules, the Hercules, just the one that came out 2-3 weeks ago, as you can see here in the issues. And by the way, you'll see me here as a very, very busy tester. I haven't worn, so yeah, you see me here. I'm very busily testing it, and it is very stable. I put a ton of load onto it. There were some minor bugs, but they were fixed. Nothing big, but they were fixed, and it is now working. So today in the video, we're going to see how you can install your own Hercules and play with it. So before we do that, let's remove again Hercules, because we don't need to show the stuff anymore. Oh, already removed it. Apt. Apt. Yeah. Okay, so that's done. Now I want to create a new directory. I want to take it from GitHub directly. So I'll go up here and we just say copy, clone the repository. I just copy this link here, and I say git clone and then the link. It takes about 10 seconds or so on my very slow connection. Okay. And now we'll go to the util directory, and we'll see what building tools we miss. Okay, so it tells us which tools we need to install. So let's do apt install autoconf, because it tells us to install this one. Automake, flex, We don't have the compiler. M4, the preprocessor, make is not available. And I also know it doesn't tell you, but you will also need to install G++. So very important. If you don't install G++, it won't work. It doesn't tell you, but you need it. It's just a little bug there. Takes a second. Now there's one more thing we need to install, and that's the zlib and the bzip libraries, because we're going to be using those. Now I always look for Ivan Warren's comments. Hercules, zlib, devil. Okay. Right, so if you search for, see here, search for basically these terms here, zlib devil and bzip2 devil, and Ivan Warren, one of the main authors of Hyperion, you will come upon this. I'll put all these packages here in the description below this video, so you don't have to go search for it. All the links will be below this video. So we copy this, apt install. So that's what we need for. This is the source code, so that of the zlib libraries, so that Hyperion or Hercules can then use these libraries to compile itself. And we also just the bzip2 libraries. We do the same thing. Okay, these two are kind of important, so you cannot skip this step. That's very important. And again, I'll have them in the description below this video. Okay, so now we have this installed. I can go one level up, and well, let's just run a check again to see if we have everything. Yes, so now it tells us okay for everything, including G++, which it doesn't check for, but it is absolutely required. So now we can we build Hercules now. So follow carefully, autogen, type this within. I do this within the Hyperion directory. I know that the formality police will now come and say don't build inside your Hyperion directory, because, well, I still do it and works fine, don't worry. So this is how I do it, and it's been working very, very well for me. Yes, you can create your own build directory so you can have different builds, but I'm just showing you here right now how to get a compressed 64-bit volumes working. So you run this command, autogen. Okay, so this was now all done, and now we run configure, which checks if we have all the features and libraries and support that we need to build Hercules. Now this is running on a, what kind of machine is this? Let's see. That's a ProLiant ML350 generation 9 with 12 CPUs, 24 cores, and how much RAM? 172 gigabytes of RAM, and spinning disk. So it's not going to be probably this is even on a NAS. So this is not the fastest machine, but for what we need to do, plenty enough. Okay, so this is already done, no errors whatsoever. And now comes the part where we actually compile the Hercules binary, which of course is a bigger binary. Now, when you make is the command to build Hercules. You can, if you have a single processor, you just type make. But in this case, I have 4 processors and 8 gigabytes of RAM. So I'll say make -J, and then it does a parallel compile. It's smart enough to understand which things it can do in parallel and which need to be done in sequence. So I do that, and it's now compiling. And already you see here DASD convert 64-bit. There's some new things that are being built which didn't exist in previous versions of Hercules. It's 3:30 a.m. I just came back from overseas, and I'm completely jet lagged. Alrighty, and sorry for about all the coughing in this video. I know it's not pleasant, but I picked up a bad flu overseas, in which I am getting treated with some antibiotics. In fact, I picked up a whole pneumonia. I just found out yesterday. Okay, so now it's building some libraries. We can restart an additional session to see what's going on, how busy the machine is. Yeah, it's quite busy because it's taking a while even to respond to the SSH request. Oh, this machine hung. Oh no, it didn't. It's just very, very busy. Yeah, when you do my make -J, yeah, here it is. It just takes up all the processes. Yeah, this machine is very, very busy right now. This is Ubuntu 16.04, and just as a side note, if you run on ESX and any kind of virtualization, you don't really need Ubuntu 18.04. There's two things I don't like in the new Ubuntu. One is they redid once again the whole networking stack, so now configuration is just basically in XML files. Very hard to do by hand, and I really didn't like it when they changed the init approach in 16.04 from 14.04, and then it's just slower. There's so much more bloated software in there. 16.04 is plenty enough. I actually run probably 75% of my virtual machines with 14.04. It's fast. It's plenty good. You don't really need all the new features of 16.04. Yeah, there's some interesting things, but there's still bug fixes. So yeah, it wants me to upgrade to 18.04, and that's not going to happen, my friend. So yeah, the machine is just very, very busy. And the problem with that is because I'm running on a NAS, so everything's going, all the read and writes are going over network interface, which I have bonded, so it's 4 network interfaces going out into a switch, and then from the switch with 4 bonded gigabit interfaces into the NAS, so it's effectively 4 gigabit. But still, it's not the same as writing on local spinning disk, and of course it's not the same as writing on SSD, and obviously it's not the same as writing on NVMe disks. Nowadays, if you run a production system, I would advise to run on NVMe for the main files, and then back it up daily onto spinning disk. NVMe is just such a joy to work with NVMe disks. It's blazingly fast. So a few more words about the CCKD4 64-bit support, so 64-bit support for compressed files. It's very stable. Now you can do two things. You can just finish compiling it. So you can either compile it, make the DASDs from the beginning in 64-bit. They have to be defined as 64 bits. Created with DASD in it, or you can convert. Okay, and we're going to look into that as well. You can convert existing 32 bits into 64-bit DASDs, but they have to be converted. They will not automatically become 64. But you can't just say, "Hey, I defined with an old Hercules a 3390 Type 9, so therefore 9 gigabytes DASD device, and now I'm going to use it with the new version of Hercules, and it's automatically going to be able to write to all the way to 9 gigabytes. No, you have to first convert it to being 64-bit, because the two things need to continue to work in parallel within Hercules, and they're sufficiently different that there's really 2 DASD supports programmed into Hercules. So that's really key, that you understand that you can't just think that because you defined it as a 27 gigabyte with the old version of Hercules, that it now will automatically be seen as 27. No, you have to convert. So finish compiling, And now we just have to say make install. And I say the series of commands again if you want to write it down, but this works reliably. Okay, so again, this is a bit slow because it needs to write over NAS, but it just takes 2-3 seconds more. On NVMe it takes about 2 seconds, here it took about 12. Okay, so now we have Hercules basically is installed. And so again, the commands are, if you want to write the sequence, autogen.sh, you run that after you obtained all the missing components for building. As we said, then you say configure. Okay, after you finish configure and there were no errors, you say make -j. Okay, and after you say make -j, you say make install. That's it. And of course, again, in this directory it tells you run this thing here, and it will tell you if anything is missing here, you cannot build it. You have to go again and install, but it just takes a second. Okay, so now I'm back to the root directory here, and you don't need to be root for building, but you need to be root of course to install it so that everybody can see it. Only the last step requires to be super user. Everything else you can do as your normal user. I know that people don't like it. I always work as root, but I grew up working with Unix in the 80s and 90s when all the stuff you always did as root, and the super user is just kind of still a new thing for me. All right, but of course the proper way would be and safer would be to work as super user. So now we have Hercules installed. Okay, and it should tell us that we have with Zilla support, okay, and with CCKD, so with CCKD 64-bit support. So now we have the most modern Hercules, and of course all the vastly improved hardware instructions. So this is the best Hercules you can get right now, and it's very stable, I have to say. And of course also things like ZVM will now work very reliably on it. So we know we have Hercules installed. I go to Ubuntu and let's see what work we need to do to make this DASD here become 64-bit compressed. So let's remove this MOSHIX because we don't really need it. This is okay. Now we want to make this Ubuntu become a bigger disk, 64-bit. So for this we have the convert, okay, and we just run it, and it tells us how to run it. You run this by saying das convert options in file out file, simple enough. Das convert 64. And we say, what is it called? Here it is. Oop. Okay. Das convert. Okay, and we say Ubuntu 64. Just go like this. Yeah, it is already compressed, so obviously we need to say das copy. So to convert it, we need to say das copy 64, and then compress using zlib -a again, and then the input file. We have to say the type also, sorry. So -z for compressed, -a for alternate cylinders, -o CCKD 64. So we want CKD this is, compressed. We could also copy into non-compressed, but then it would just occupy a lot of this space. So -O, and now the name of 64. Okay, so now it's converting. Takes a little while, and why is that? Because it needs to read, uncompress, and then compress again and write. So it's doing the same operation twice, and that's why it's a little slower. Plus, I'm working over NAS here. If you have a spinning disk on local on your computer, it will be a little bit faster. I'll pause here until we're done. Okay, so this finished. Let's see what came out. So the interesting thing is that this is slightly smaller, and I think it's because it also reorganizes and the new DASD a little bit and remove things that it knows it doesn't need anymore. Not much, maybe 3-4 megabytes smaller. But so now we have the 64-bit. Now one thing I want to show you is if I start up this machine, this mainframe, you'll see that it says 3390 DASD, okay, with 10,000 cylinders. So that's actually, as you'll see here, that's already defined as a Model 9. But this one still won't be able to be read and written as a Model 9 because it's just a 32-bit. We'd have to go and change the definition in the configuration file for this Hercules machine to move to 64. Alright, so let's do that. I start the world's best editor, and I know that people have different opinions, but that is a fact. You will find it also on Wiki. I think Wiki says it's the best editor, and also René Ferland says it's the best editor, so I believe them. I'm not going to argue with them. Okay, so this is a little thin on the memory. Let's give it 7, 4 CPUs. Okay, alright, and just go here and make it 64. This is how we named it. We could call it Mickey Mouse, but I just call it 64 so I can keep them apart. And then we have some network thing going on here. Alrighty, so this is nice and easy. Set up networking, and let's start. Oh, one thing is I always like to operate within screen so I can have multiple virtual sessions. Okay, so Hercules, Ubuntu, and you'll see something now. Aha! What is this? Now Hercules tells me this is a 64-bit volume. Okay, so from now on you will have to check this, and this column to see if it's a 32-bit or 64-bit volume. This is a 64-bit volume because we use this one, you see, 10,000 cylinders. Why don't we try to IPL this machine? IPLC. It will start booting on its own. Okay, it's coming up. It auto senses all the CPUs, so I don't have to tell it anything. It's not running it. 62 MIPS, which is decent. I really like this this machine here. It's quiet. You can. It's a server, but it's not a rack mountable server. It's a tower, really big tower, a heavy tower. But it has 2 sockets, so I can put in 2 CPUs. And these ones are reasonably fast. I could upgrade to 3 gigahertz ones, which I will do eventually when the price comes down. And you can add up to 1 terabyte of memory. And then you have tons of space for DASD, for disks inside. So this can be expanded. This can go. This, you can just work with this machine. You put this in a home lab, it's going to be powerful enough. I also have some other stuff, like I also have this machine here, which is what is this? 3650 M4 with 16 CPUs, but those are 2.9 gigahertz, and I think this has 393 gigabytes of RAM. And I also have an M5. I think it's with 3 terabytes of RAM and 60 CPUs at 3.4 gigahertz. But I had to take it to the office because I need to copy some virtual machines over it, and so I don't have it here right now. But it's a really nice machine. Okay, so I think this finished IPL. Yep. So let's root. Yes. My amazing password. And you'll see now that, yeah, this is busy calculating keys. This is the crypto, the SSL libraries, keeping busy. Yeah, okay, so we're in. And we see, of course, Linux sees here a smaller disk. And why is that? Because when we formatted it, it couldn't reach beyond 32-bit. So we could go with fdisk and expand it, okay, and then make it the full 8.5 gigabytes. So that is certainly possible. You can expand the partitions. You would have to do a little bit of work, but that it's all doable. So you see now that this works fine, and we could start writing stuff to it, and it will work just fine. So it's very stable, 64-bit support. But one thing I also notice is that, because I know my computer so well, is that it is faster indeed. This Hercules version is much faster than the Hercules 3.12, which I had previously on this computer. I could shut it down and we could run some benchmarks, but this is a topic for a different video. But so I can feel the difference. It is faster. I don't know what I have here. I have nothing on this image. Do I have access to Yahoo? No. I need to add route path default gateway. No, I didn't set up any NAT forwarding on the underlying Linux on the inside on the Linux underneath. But if I did, then I could, of course, access the internet through my router. So that is all working. Google DNS. Yeah, I don't have NAT enabled yet. I would have to go under Hercules, on the Linux under Hercules, and enable NAT, but that's not. It will work. That's not the issue. So yeah, I mean, I don't really know anything else other than showing you this. This works just fine. It is S3090X, so that's 64-bit, and this all runs fine. So we saw how the difference, the various DASD versions are if you define compressed or uncompressed. With older versions of Hercules, you only have 32-bit, including older Hercules you install with the package managers, including some of the including the Hercules that comes as part of TK4, MBS TK4. But of course, there it doesn't matter, because in TK4 I don't think TK4 supports 33 90s beyond Model 3 anyway. That all works now. You'll see that now you have this indicator. We saw how to build Linux, how to obtain all the build tools, and then the 4 commands to build it. And you see this is pretty stable. It is faster because some instructions have become significantly faster, especially ones that have to do with moving more than 1 byte at a time, like MVC, MVCL and other instructions. It is really much faster. Also packed instructions became faster. So this is it. This works. There's nothing else I know what to add. So thank you for viewing this video and all the other videos. You will find all the links and commands again in the description below this video. If you like this particular video, do press on the thumbs up button. It helps with the Google ranking, and when people search for topics on Google, it will find things easier on YouTube if they have lots of thumbs ups and lots of comments. Comments, I think, are the #1 thing that makes Google find things on YouTube. They changed the algorithm this year. So comments are very much desired to make the whole world aware of all the help that we here provide in the community to ourselves. And so switch to this new Hercules SDL Hyperion as soon as you can, because it is worthwhile doing it, especially if you run things other than MVS and the VM370 such as OS 390. Etc. I'll be making some videos soon about the use of my freshly obtained IBM 390 cards, where I'm now running VM-ESA and OS 390. And I want to do a benchmark between the 390 cards and Hercules, just to see how much faster modern computers are. Because of course those cards, I think they're only 33 megahertz or maybe 60 megahertz, so very slow cards, but they are able to legally run OS 390 and VM-ESA, which I did in the video I released just shortly, a few days ago, about reviving VNet as HNet for the community. So that's it. Thank you, and season's greetings to all of you. Goodbye.